Okay, so here we are. This is a really short lesson, but basically it completes our discussion of measures of dispersion. Because what we need to do now is that we need to look at grouped data. So data that we have where we've got things in intervals. Because
no raw data.
How do we find, just like we had the question, how do you find a mean when you've got grouped data?
Yeah.
How do you find a standard deviation when you've got grouped data? So let's recall measures of dispersion.
Measures of dispersion for ungrouped data, or raw data, we've been calling it, takes each individual data point and says, how far have you strayed from the mean? How far have you strayed from the mean? And so when you've got each individual data point, you can do that because you've got all your raw data and you can just compare each one. Mm-hmm. But the same conundrum we had if we've been given a frequency table and no raw data, and then we're meant to find the mean, the median, and the mode. Mm-hmm. If we're given a frequency table and we're meant to find the standard deviation, variance, or range, then the best we can do is estimate. So we just want to highlight here that this is going to be the least specific, right? The least accurate way of finding standard deviation compared to finding it using the raw data. So, but we're going to use similar methods because so we don't have data points. That's okay. We know how many data points are in a certain interval, and we're going to find the average data point with the midpoint. So we're still going to use frequencies and midpoints, and it's going to be the same process. It's just the formulas look a little different because of the fact that we don't have real x values. We got m's, we got midpoints.
And so here we go. And again, measures of dispersion for grouped data. So basically, we're talking about the standard deviation, okay, for a population and for a sample. Mm-hmm. And here, just like how we had with the mean, how we had, we had the frequency and the midpoint. Here what we have is how much does the midpoint of our given interval vary from the mean?
Yeah.
We square it.
Yeah. We
multiply it by the frequency. Yeah. We add all of those together. We divide by n minus 1.
And if we stopped there, that would be the variance.
That would be the variance.
But then we square root it to get
we square root it, and we get the standard deviation.
Yep.
This, to me, when I look at this seems like a lot.
It seems like a lot of work.
Yeah.
In Excel, it is not a lot of work at all. In fact, it's only one more step added on to what you did before.
With the frequencies and the midpoints.
With the frequencies and the midpoints, except that it is a little bit harder for you to find your x bar. So if we don't give you the x bar, then you have to go back and use the method of finding the mean for group data using frequencies and midpoints, and then you use that x bar to find the standard deviation using frequencies and midpoints. So it takes a little bit longer, but because we got formulas in Excel, we can get there faster. And notice the same thing, the denominator is still little n minus 1 for the sample because we want to create a little bit more variation to match the variation we might find in the population. We're compensating for the fact that samples are not as varied as the population. Okay, just a little reminder.
All right.
Might show up in a multiple choice question.
Again, we should probably say this too, that F is the frequency for a given interval. M is the midpoint of that interval. And we should note that calculating standard deviations from raw, ungrouped data, again, more accurate results. These are estimates because we've lost information. We put stuff into groups. We don't have the same amount of information. Here we go. Use Excel to calculate the standard deviations for the salaries that are listed below. So we get $28,000, we get $30,000, we get $32,000.
Yep.
We get $43,000, we get $36,000, and we get $38,000. So these aren't in order, but they're also not even midpoints, right? So we haven't even given intervals. We're not interested in intervals. We've got the midpoints of certain intervals with the frequencies that they hold. Yep. And I guess if you were going to do this, 28, 30, 32, 34, 36, 38, 40, 42, you would have to assume that anywhere where we haven't, we've got a 0, which doesn't affect our calculations.
Yep.
So let's use Excel to do all of this. Mm-hmm. We're going to get out of this. We're going to flip over to our Excel spreadsheet, and here we go. Midpoint salaries are right here. Now, we've gotten rid of the 1,000 because we don't need to. We just have to remember that when we find our standard deviation, it's going to be based on multiples of 1,000.
Yep.
Okay? So we've got our frequencies and we've got our midpoints, and this is what we've started with. And so look at the progression that we're going to take to get up to our standard deviation. So we're going to step you through this one.
Yep.
And Ms. Hughes, while I type, You can tell me what to do.
Talk you through. Okay, so if we want to find the variance in standard deviation, then we know we need to do m minus x bar. We've got our m's, there they are in column A, but we don't have our x bar yet. And again, do not be tempted, if you can picture me, I'm shaking my finger at you, do not be tempted to just select these data values and just do average, because that implies that there are only 6 data points in the whole sample, and there are not. There's quite a few more. So again, think of it like a weighted mean where we've got 4 of these, 6 of those, 7 of those, 4 of those, 2 of those, and 1 of those, and we're going to do equals, and then we're just going to click on that, use our asterisk for multiplication, click on the frequency, and then hit enter. Now we can autofill down because we're happy with both of those values changing each time that we change our F times M column. And so if you recall that to find the mean using group data, we do the sum of all the frequencies times midpoints. And then we divide that by the sum of all the frequencies. Okay, so Mr. Jackson's just going to go in there and find the sum of all those frequencies. And the sum of all those frequencies is our n. It's our number in our sample. Okay, or if it's the population, it's the number in the population. So if we want to find the mean, we're just going to click in there and we're going to say equals, and then we'll do C9, we'll click on that, okay, and we'll divide by B9. Oh, divide by. Mr. Jackson, what? He's in the mode to subtract.
Divide by.
We're going to divide
now,
by.
Now, are we going to subtract 1 from this?
Now, if you recall that for means, we always divide by capital N or little n.
Oh, yeah, that's right.
Okay.
So we don't want to.
We don't need to make any changes there. It's only for variance and standard deviation that we compensate because we are looking at variety, right? Whereas this, we are looking at an average midpoint, right? Like the center value or central tendency.
All right, so there's X bar.
We got X bar.
So the mean for this for these salaries is basically about $33,000.
Yep. So now let's go into M minus X bar, and we know we want to type in our equals. And then we'll select the midpoint for that row, and we'll subtract our X bar. Now let's go in there, Ms. Jackson, let's do absolute cell referencing.
Because we don't want this to change.
No.
We want to reference this cell all the time,
yeah,
no matter where we go when we do our autofill.
And then that way we can autofill, and we don't have to worry about losing values. Okay, so we've got, again, some of our midpoints are below the mean. So you can see they're negative, some of their midpoints are above the mean, and then we're just going to do equals, and then we'll select D2 and do the little hat or the exponent 2, so we're squaring that, hit enter, autofill it down. This is a really quick process. As long as you know what to type in, then it's actually really fast. Now, we go over one more column.
And we should note that you don't have to memorize. You don't have to memorize M minus X bar, M minus X bar squared, M minus X bar squared times frequency. You don't have to memorize this. You just have to look at the formula, right? Because the formula is right there. It tells you what you need to do.
Yeah. Now the reason we're multiplying by F is that if we just add up those M minus X bars, again, it looks like there are only 6 data points. But we know that we're weighting them in that there's 4 data points that have the deviation or the square deviation 27.5625, and there are 6 data points that have the square deviation 10.5625 and so on. So we need to just make sure that we're saying 4 of those, 6 of those, 7 of those, 4 of those, 2 of those, and 1 of those, and now we sum that. So the sum of the frequency times the square deviations for each midpoint is going to be the numerator of our grouped variance formula. Okay, so that's a mouthful. And because this is a sample, Mr. Jackson's going to say equals, he's going to click on that, and then he's going to divide by. Now, if you want to make this obvious, you can actually open a bracket and do 24 minus 1. Because we know the sum of the frequencies is 24. That means it's 24 data points. We'll close the bracket, we hit enter, okay, and that's our variance. Okay, or S squared because it's a sample. The standard deviation is just the square root of the variance, so you just type in your equals, squirt, select the cell, close the bracket, and hit enter. Okay. So now we've got our standard deviation for the sample is 5.1 or 5.12, depending on what you want to say. We've got our variance, we've got our mean, and we're good to go here, Mr. Jackson. We got
so we should say that the spread of these midpoint salaries, the average deviation of these salaries is about $5,000. Really, it's about $5,100. Now, if we had a couple salaries in there, say perhaps maybe a CEO who's making $90,000, $100,000, $200,000, of course, this standard deviation would go way up because now we have outliers and we have
Bigger spread.
a much larger spread.
Yeah.
So these are all pretty packed together, and we can tell because this standard deviation of about 5,000 in comparison to $28,000,
Yeah.
$32,000,
Or even the mean.
or even the mean, which is about $33,000, is relatively small.
Yeah.
So coming back to this, we just wanted to summarize, that this is basically what we've got, the full sample standard deviation, about 5.1, which is exactly what we found here. And that is basically a typical example of how we work standard deviations
With grouped data.
with group data.
Yep.